Okay, sorry about that. So work is equal to the voltage times the charge. So if I know power, I know work is voltage times charge. I can just put in P is equal to VQ over T. Q over T is our definition of current, so I get P is equal to IV. So we've got Ohm's law, Joule's law. If we really want to understand circuits, we need to understand two more laws, this time all given by the same guy. So this is Kirchhoff's rules. So Kirchhoff's rules, there's two different rules. The first is the junction rule. So basically the junction rule is when a wire splits or combines, the total current from that junction is equal before and after. So if I have one wire splitting into two different ones, the current I2 and I3 have to equal I1. Or if I have two combining, I1 and I2, I3 has to be equal to the sum of these two. And really this comes about because of a consequence of conservation of charge. Any charge flowing here, when it gets here, it can't just disappear and more charges can't be created. It has to be the total charge going through here. So this behaves very similar to fluids back in the day, and the whole reason why we use the word current is because they thought that electricity was like a fluid, and this is just one of the rules that kind of came out of that line of thinking. And honestly, it works well. So the junction rule is basically any current coming in has to be equal to the current coming out of any junction. The second rule is called the loop rule. So the total voltage around any circuit loop is going to be zero. So the voltage would be provided by the battery, and then we have voltage drops at all of the resistors. So basically, when we go around a battery, so if I have a 12 volt battery here, and I have two equal resistors, the voltage drop would have to be 6 volts. So if I measured from here to here what the difference in voltage is, it would be 6 volts. And then from here to here, it would be another 6 volts. If I have two equal resistors. If the resistors aren't equal, then I would use Ohm's law to figure out the ratio of these. But whatever they are, they have to add up to 12, no matter what. So this is basically going to come from another conservation law, conservation of energy. Which makes sense. If we're talking about voltage as kind of the proxy for energy in a electrical system, then we can't have more energy coming out or less energy coming out than we're putting in. The last things that we want to talk about are series and parallel circuits. So basically, series circuits are one loop. They're going to look like this. So if we're taking a look at a series circuit, it's going to have multiple resistors hooked up along one loop. So from Kirchhoff's junction rule, well, are there any junctions in a series circuit? No, because the wire doesn't split anywhere. So the total current is going to be equal. So the current through I1, I2, and I3 all have to be equal to each other. And that goes for no matter how many resistors we have hooked up in series. It would always be equal to whatever the total current is. Total current in a series circuit is always the same. The loop rule says, so how many loops do we have? Well, we have one loop, right? That's the loop that our current's going through. The loop rule is going to say that the voltage from the battery is going to be equal to the voltage change across R1 plus R2 plus R3. So V1 plus V2 plus ... for however many we have there. And then to come up with the total resistance for the circuit, so the equivalent resistance of this circuit in series, we just add up all the resistors. The next, okay, so if series has one loop, guess what? Parallel has not one loop. So in a parallel circuit, there are two or more loops. So that means, so we would have this loop here, this loop here, and this loop here. We could consider other loops, so we could consider this loop here, but hey, there's no voltage source on this loop, so the drops on here would be 0 because we have no voltage source. Same if we chose that loop or this loop. If we don't have a battery in the loop, we can really just forget about it. So the junction rule says that the total current going through here is going to get split here and split here and split here. So basically the junction rule says if I've got the current I1 here, I2 here, and I3, the total current is going to be the summation of those three. And then if I have more circuit elements connected in parallel, I would have, more to add up. The loop rule says since every loop is on its, basically has the voltage being the same, we get V total is equal to V1 is equal to V2 is equal to Vn, no matter when you get to Vn. The equivalent resistance is really the weirdest thing about parallel circuits. The equivalent resistance is 1 over R1 plus 1 over R2 plus ... 1 over R to the n. So we have to find the summation of the reciprocals and then take the reciprocal of that. Now, this has a weird consequence. So the REQ is always less. No matter what you do, you're going to get an equivalent resistance that's less. Now, at first, you're like, well, how can I take two resistors, hook them up, and get less resistance? That doesn't make any sense. But if you think about this as like opening up more paths, so more loops would equal more paths, and each loop has its own current associated with it, basically it makes sense because there's more ways for the electricity to flow, so the total resistance is going to be lower. Compound circuits. Compound circuits have portions that are both series and parallel. So when we take a look at this one, this resistor here is in series, and these are in parallel. If I wanted to figure out the equivalent resistance of this circuit, well, basically, this is in series with these two, so I would take a look at the equivalent resistance here, which would be 1 over whatever our values are, So we'd use this to figure out what this is, and then the total resistance would be that series resistor plus the equivalent resistance for that parallel part. On these ones, these two are connected in series, and these two are connected in series too. So to figure out these ones, if this is R1, R2, R3, and R4, then my equivalent resistance here would be equal to 1 over, so these add up because they're in series, so 1 over R1 plus R3 plus 1 over R2 plus R4. So basically, no matter what compound circuit I have, I can look at it as a bunch of either series or parallel elements and add them up accordingly. Okay, that's all I have for this video. See you later.